So the second part to section 4.2 is going to talk about area, but we're going to talk about upper and lower sums. And the way that we do that is we talk about something called RAM, which stands for Rectangular Approximation Method. So this allows us to find and approximate irregular shape regions by using rectangles to find the area. So there's 3 steps that we're going to follow. Step 1, we want to graph it. And it's either going to be on an actual coordinate plane, or you can actually do a number line effect. We're going to break up the area regions into equal widths, which are equal to delta x equals b minus a over n. And then we're going to create a formula. Now, area of a rectangle, we know the formula is base times height, but they're going to be looking a little bit different. So now it's going to be delta x times f of x. So when we do RAM, there's 2 RAMs that we're going to do. Something called LRAM, which stands for left rectangular approximation method. And we're going to do RRAM, which stands for right rectangular approximation method. Now, when we do these, there is also one that goes in the middle, MRAM, but we don't do that one in here. So we're only going to do the LRAM and the RRAM. All right, so I'm going to lean more towards creating a number line rather than creating a coordinate plane, just because it's not necessarily needed. Let me show you what it looks like, though. So if this is our parabola, we know that it starts at the origin. And the question is saying, okay, well, we're going from 0 to 3. So say here's 0 to 3. And here's that point right there. Okay, and we want n equals 6. Well, that's the number of rectangles. So basically what we would have to do is we would have to be creating 6 different rectangles inside of this very teeny space. And what you would do is you would figure out what all the different areas of those individual ones are. So that's a little hard. So what I always recommend is, all right, let's do a number line instead. And we only need to focus on the parameters that are given, which are 0 to 3. The other piece, which I like to take at the same time, is let's calculate our delta x. Well, delta x is b minus a over n. Well, your parameters are your a and your b. So it would be 3 minus 0 over n, which is 6, which is 3 over 6, which is 1/2. That is indicating to you what you want to break down this particular interval in. So if I go 1/2 away from 0, that's 1/2. 1/2 away from 1/2 is 1. 1/2 away from 1 is 3/2. 1/2 away from that gets me 2. And 1/2 away from that gets me 5/2. And then I get 3. And then what you want to do is, if we're saying this is broken down into 6 rectangles, make sure you have 6. So 1, 2, 3, 4, 5, 6, which we do. Okay, so we have 6, so we're good. So if you're asked to graph it, again, I stress the number line. I just think it's easier than actually graphing it, because you're going to see some pretty ugly functions that you're going to be asked to graph. So the number line is definitely easier. Also, show me how you calculate the delta x. And now what we're going to do is we're going to do LRAM and RRAM. So these take a lot of time. They're not difficult, but please make sure that you are writing each and every step out, or else you are going to lose the credit for not showing all the work. So the formula you're supposed to use is delta x times f of x, and that goes for both of them. Okay, and LRAM, again, it starts for left rectangular approximation method. So the delta x we know is 1/2. And then what we are going to do is we have our f of x function, which is x squared. So f of x is x squared, and we're looking at our number line. We're going to start furthest to the left, which would be 0. And I'm going to sub 0 into my function. So my first term is 1/2 0 squared plus delta x times the next one, 1/2 squared for the next term. And I'm going to continue this process until I have accounted for, it says we have 6 rectangles. So you want to make sure that you've accounted for 6 rectangles. So 1, 2, 3, 4. I have 4 terms so far, so I have to keep going. I got 2 more. So I have 1/2 2 squared plus 1/2 5/2 squared. So that's 6 terms right there. So those are the 6 that I needed. Again, though, you're starting with the leftmost number, and you're not going to get all of them. You're not going to get the furthest one on the right. So now what you do is simplify. So the first term, 1/2 0 squared is 0. 1/2 squared is 1/4. Times 1/2 is 1/8. 1 squared plus a half is a half. 3/2 squared is 9/4. Times a half gets me 9/8. 2 squared and 2 gets me 2. And 5 over 2 is 25 over 4 times 2 gets me 25 over 8. Okay, and then you have a calculator for this. So now what you can do is type it in. You get about 6.88 for your LRAM. Now what we're going to do is, again, it takes time to write it out. So just make sure, don't shortchange yourself. Don't do too much math in one. I need to see the line where everything is subbed in, and then the numbers after it, and then the final answer for that. So now for RRAM, we're basically doing the exact same thing, except R stands for right. So now what we're going to do is start at the rightmost side. So it's 1/2 3 squared plus 1/2 5/2 squared plus 1/2 2 squared plus 1/2 3/2 squared plus 1/2 1 squared. Let me see, 1, 2, 3, 4, 5. I need one more. Plus 1/2 1/2 squared. Okay, and the nice thing is we've already calculated most of these. The only one we didn't calculate was the first one. So 3 squared times 2 gets a 9/2. We know that when the 5/2 goes in, it's 25 over 8. 2 gets me 2. 3/2 gets me 9/8. 1 gets me 1/2. And 1/2 gets me 1/8. So I already have all those numbers done from LRAM. So there's no need to recalculate, but the work line needs to be shown. And this gets me about 11.38. All right, so the idea is we're figuring out the approximate area under this curve. Well, I have a left approximation and a right approximation. So when you write your final answer, we're going to write it as a compound inequality. Lower number goes on the left. We'll do unit squared. Larger number goes on the right. And we're going to do unit squared. So it's going to be a compound inequality, putting those two answers together. Now, what made that one so big is because the number of rectangles was so big. So you're going to see how these get a little bit shorter. All right, so now we have a trig one. Now, imagine trying to graph that one. It's not easy. So let's do delta x first. So b minus a over my number of rectangles, which is 2. So I get 2. Here's my number line. I'm going from 0 to 4, and I'm breaking it up into 2 intervals, which have a span of 2. So I get something like that. So now, given that you see the sine function, this needs to have your calculator. It needs to be in radian mode, so make sure you do that. All right, so LRAM tells us if it's delta x times f of x, and I only need 2 rectangles, so I only need to add 2 things up. So delta x is 2, and then it's 0 squared sine 0 plus delta x times 2 squared sine 2. 0 gets a 0. 2 gets a 7.27, which gives me an LRAM of 7.27. For RRAM, same idea, but now we start on the right. So I'm going to start delta x, and then 4 goes in first. And then I have 2. So type that in. You get negative 24.22, so it's a negative, which is fine. And the 7.27, which gets us negative 16.95 for that. So again, it doesn't matter where the numbers fall in terms of do they necessarily make sense. The left should be the smaller one. Whatever the lower of the two numbers, so that's negative 16 or negative 16.95, that goes on the left. And the 7.27 goes on the right for your final answer. It's an approximation for these. All right, one more final one. So delta x first. So 2 minus 0 over 4 gets me 1/2. Number line, 0 to 2, and we're breaking it up into halves. And you check 1, 2, 3, 4. So there are 4. Now for LRAM, we do delta x. Start at 0. 2 times 0 minus 0 squared. 1/2. 2 times a half minus 1/2 squared. 2 times 1 minus 1 squared. And we're adding 4 things up because there were 4 rectangles, so I'm getting up to 3/2. So when I simplify, I get 0, 0.375, 0.5, 0.375, which is 1.25. For RAM, I start at the right. So I have 1/2, 2 times 2 minus 2 squared, 1/2, 2 times 3/2 minus 3/2 squared, 1/2, 2 times 1 minus 1 squared, plus 1/2, 2 times 1/2 minus 1/2 squared. So that gets me 0.375, or actually, no, sorry, that's 0, 0.375, 0.5, 0.375, which is going to get me 1.25. Okay, now, remember, this is only an approximation. So these two numbers are right in the ballpark of each other. So that means the area is about 1.25 units squared. So there are going to be times where you get the same interval or that you get the same final answer, which is fine. Again, just make sure that you're writing that it's an approximation for these. So for all these problems, when you get to them, you're going to be